Right, chapter 8, we're going to continue our discussion on reactions. And in this particular case, we're going to talk about alcohols, phenols, which remember are alcohols on aromatic rings, and ethers. So alcohols, remember, are anything that has an OH. A phenol is a specialized alcohol. It's one with an aromatic ring. And then an ether, remember, is a carbon, two carbons with an oxygen in the middle. So we'll talk about both of them. First, we're going to talk about how to name alcohols, phenols, and ethers. We kind of slowly have talked about it, but let's get a little bit more formal about it. So alcohols, same thing. Look for your longest continuous chain that includes the OH group. Okay, so longest chain with OH group. All right, start counting the side closest to the OH. Count side closest to OH. And the end of your at the end of the name is going to end in OL. So alcohols are alls: ethanol, methanol, isopropanol, and then name the substituents accordingly. You could have more than one functional group, but we're not going to get too complicated with these naming. So basically, you're going to start on the side closest to the OH, which would be the left side. So this is carbon 1, 2, 3, 4, 5. And the naming is kind of like the double bond. You put the number right in the middle of the name and the OL part of it. So this would be called pent, pentan-2-ol. You might even see the name penta-2-ol, or you might see pent-2-ol. Okay, this first one is the most correct way because the older way of naming things were pentanol. That was the old way of naming it. Alright, so another example would be, let's say you have two OH groups. Alright, so this would be called cyclohexane 1,4-diol. So if you have two, it's di, 3 tri, 4 tetra, so forth, so on and so forth. All right. Another example, just to get a little bit more of a complicated one. All right, this time you have a substituent, but start on the side closest to your double bond. To your OH group. So 1, 2, 3, 4. And you got a phenyl ring as a substituent. So this would be 3-phenyl. Butan-2-ol. Alright, rules are the same as what we've been doing. It's just we now just have another functional group. Okay? Let's talk about phenols. We learned in the aromatic chapter that a phenol is a special type of alcohol. And basically, all depending on the substituent hanging off of it, so like in this case, this would be called meta-isopropyl phenol. Alright, so your parent is the phenol group. And whatever groups you have attached to it, you just name accordingly. All right, nothing too tricky. Ethers. There's two ways of naming ethers. There's ether as the parent, which is kind of a common name, and then there's ether as a substituent. If you have simple ethers, a simple ether. What's a simple ether? Simple ether is where you have two groups hanging off of your ether that are very easy to name. Okay, so notice I have an ether. I got two R groups technically. I have an ethyl group, and I got an isopropyl group. So, since these groups are easy to name, you alphabetically name it, and it's called ethyl isopropyl ether. Very simple. You name one side of it, you name the other side of it, followed by ether. Now this is if your ether is simple. So let's say you have an ethyl group and you have a methyl group. So this is called ethyl methyl ether. Okay. Ethyl methyl ether. If you have two of the same groups, an ether that we've used in class, this is called diethyl ether. Because you have two of the same groups. So there's two of them, and they're both ethyl groups, so diethyl ether. Okay, very easy, very simple. This is if you have two groups that you can name easily. Let's say, however, you have a group, and it's not easy to name. So, let's say you have, let's put chlorine here, and let's put this group hanging off of it. Alright, so notice in this ether, you have a methyl group on one side, and then you have something much more complicated on the other. Okay, so if this is the case, if one of your groups is complicated, your ether is no longer the parent. It now becomes a substituent. So, kind of ignore the ether part, the oxygen methyl part, and just look for your longest continuous chain, look for what functional group you have. So in this case, your longest chain is right here. You have a chloro functional group, a methyl, and then you have this substituent. Okay, and if this is the case, if your ether is a substituent, it's an oxy group, ends in oxy. So in this case, this particular group is called a methoxy. If you have an ethyl group, it's called ethoxy. If you have an isopropyl group, it's called isopropoxy. Okay, it's kind of fun to say. So it now becomes a substituent, and that's the name. So name this accordingly. This is methyl. This is methoxy. This is a methyl group. This is chloro. So this would be called 2-chloro. Now you alphabetically you have a methyl and a methoxy, so you're going to use the oxygen versus the Y. Oxygen obviously alphabetically is first. So this would be a 1, 2, 3, 4 methoxy, 3 methyl, and how many carbons do we have? 1, 2, 3, 4, 5 pentane. Okay. Now you'll always have at least one simple group on your ether, and then the other one might be a little bit more complicated to actually name. Okay? And in that case, this is the substituent.